Okay, so reactions with esters. Let's just go over a couple practice problems just to help visualize what's going on here without having to work out a detailed mechanism. Yeah, so the premise of these is of a reaction with an ester is just to replace the OR group of that ester with whatever you're adding. So let's take a look. Say we have this ester here, and we're going to react it with water. And let's remember these reactions all tend to need an acid. The acid is for when you have like a weaker base like this here. It doesn't it takes a really long time if that reaction even would occur. So the acid will speed up that and help it happen in a timely manner. So all that this is going to give us is, let's see, we were replacing the ester part here, or that OR part there of the ester, with this group, and we're going to, if it's an uncharged molecule like this one, we're going to lose a hydrogen, much like acyl chlorides. So if you add water to an ester, that is going to give you a carboxylic acid. Your side product, if you're curious, would just be OCH3. It would get protonated. That's just this part here, and a hydrogen will protonate that. Okay, so hopefully you can see how this OH just came right from the water. And okay, let's just say we added OH minus. If that was our base, a very strong base in this case, you probably wouldn't even need acid for this. That would just attack up there. Ultimately, ester would leave, and that would give us the same result. It's just in this case, yeah, you wouldn't need the acid because that would just add. Let's take a look at another one. Okay, another similar ester. Don't get confused by what's ever over here. That you can really just label that as an R group at this point when you're doing these reactions, because we know that this is where that, well, really, that site there is where the reaction is going to start. So say we're adding that with, nice long alcohol like that. Okay, now we can see that this is not a charged base like this one up here. So we're definitely going to need acid. You just draw acid as H plus like that. And we'll do the same thing. And I hope this didn't get too sloppy over there, but let's go ahead and write it out. We would just have this, which is just an R group. Still the same ester, we just replaced the OR group of the ester with this. And this is called transesterification. We just replaced it with this all right here. Remember, since it's not a strong base, we are going to get rid of a hydrogen bonding at the electronegative atom. CH2, CH2, CH3. Just like that. Okay, so hopefully it's pretty easy to visualize how that is just attaching there, and we're just replacing that. But let's go ahead and take a look at another one. Okay, a little different ester group this time. And let's add an amine with this. Okay, now with amines, hopefully we remember, from a lecture or whatever, that you're going to need to use heat for these. Okay, so you add your heat for that, and this, it's almost the exact same thing as if it was an oxygen. It's still going to be binding on the electronegative atom. We're still going to have all this the same. R group is replaced with bonding at N, CH, or oops, and H, and it's just one H because this is still not a charged molecule we're losing, so we're going to lose a hydrogen, CH3, right there, an amide group. And this is another ester. Okay, so it's still the same idea with those, nothing to get confused about. Okay, so let's try a slightly harder one here for the last one. Hopefully we've got this visualization down. And we're going to react this with what? To get this right here. And you can tell me what those are if you want. So pause the video, see if you can figure that out. Okay, we actually basically already did this reaction. You would add, let's look at it backwards if you want, just to analyze it. This, okay, we know we could add H2O if we wanted to add a hydrogen plus an acid. Or we could use just OH minus. Get the trick done for that too. Yeah, so, for these retro ones where you're looking back, trying to, think backwards for a second, just add an H if you want, and remember for the acid, or, you can just do a minus molecule and just add literally whatever group you had there at the end. Okay, so I hope that helps to visualize the reactions with esters.